Right, in this video, we want to look at Hooke's law. Forces may change the shape of an object. An object such as spring stores elastic potential energy when stretched or squashed. So when we apply a force to objects like spring, it stores elastic potential energy. And when an object such as spring is stretched, the increased length is what we call extension. So when we apply a force to extendable object, it increases in length, and that increase is what we call extension. So what Hooke's law does is to relate the force applied to the spring to the extent of the extension. So Hooke's law states that the extension of a spring is directly proportional to the force applied, provided that the limit of proportionality is not exceeded. So what this means is that if we double the force on a spring, the extension also doubles. If we triples the force on the spring, the extension also triples. Now, this is true until the limit of proportionality is exceeded. Okay, so we can represent Hooke's law with this equation: F equals to KE, where F is the force and the force should be in Newton, and K is the spring constant in Newton per meter, and E is the extension in the spring, and the unit, the SI unit of extension, should be meters. Okay, so Hooke's law simply says that F equals to what? KE. The force applied to a spring is directly proportional to the extension in the spring. So as the law states, the equation holds as long as the limit of proportionality is not exceeded. Now, what is the limit of proportionality? What does that mean? The limit of proportionality refers to the point beyond which Hooke's law no longer is no longer true when stretching a material. Now, what this means is if you take any stretchable material and you apply a force to it, you realize that it will continue to stretch until you get to a point where any additional force applied does not cause the material to extend. At that point, you realize that if you insist on applying a force, the material will break up. That is the limit of proportionality, and Hooke's law only holds true until the limit of proportionality is exceeded. Once the limit of proportionality is exceeded, Hooke's law does not hold again. Okay, now we can represent Hooke's law with the equation or formula diagram. What this means is that if we know any two, we can find the other. If we know the force and extension, we can find what? Spring constant. Similarly, if we know force and spring constant, we can find the extension. So we can find the other parameters of the equation if we know two of them. What it means is that if we know F and E, we can find K. So K is what? F divided by E. K is F divided by E, and E is F divided by K. Okay, E, the extension, is the force divided by the spring constant. All right. Now, what is the spring constant? The spring constant is a measure of the stiffness of the particular spring. And the spring constant is different for different springs and materials. Essentially, the spring constant tells us how difficult it is to either stretch or compress a particular spring. The larger the spring constant, the stiffer the spring and the more difficult it is to stretch it. So it measures the stiffness of a particular spring. So let's see how we can apply Hooke's law to work out either the force or the extension in a spring. Remember, Hooke's law says F equals to KE. All right. So the example we got here, a force of 3 newtons is applied to a spring. The spring is not stretched beyond the limit of proportionality and it stretches by 15 centimeters. Calculate the spring constant. So here we've been given the force at 3 Newton. We've been given the extension as 15 centimeters and we are required to calculate the spring constant, the K. Now remember that K is F divided by what? E. So we know that from the parent equation F equals to KE and therefore K is what? F divided by E. We know K would therefore be 3, the force, Newton, divided by the extension, which is 0.5. Remember, we were given the extension as 15 centimeters. That has to be converted to the right SI unit, which is meters. So we convert 15 centimeters to meter, we will get 0.1 meters. So the 3 force divided by 0.1, that should give us 20 Newton per meter. And therefore the spring constant is what? 20 newtons per meter. Another example here, a spring has a weight of 200 grams hanging on it and has a spring constant of 40 newtons. Calculate the extension of the spring. So here we've been given the force as 200 newton. That should be converted to the right SI unit, which is a kilogram. So 200 grams is 0.2 kg. And the force was given, the spring constant was given to us as 40 Newton per meter. So we can just put them in the equation and that should come out as 0.005 meter. The extension will be 0.005 meters. Another example here, a spring has a weight of 500 grams hanging on it and it is stretched from a length of 5 centimeters to a length of 15 centimeters. What is the spring constant of the spring? So we are calculating the K. We know F, the force, as 500 grams. That is equivalent to 0.5 kg. And E, the extension, is the 15 minus 5 because we were told that when the force was applied, the spring stretched from the original 5 centimeters to a final length of 15 centimeters. So if we want to find out the extension provided by the force, we have to subtract the original length from the final length. That comes out as 10 centimeters. 15 minus 5, that should be 10 centimeters. Remember, centimeters is not the required SI unit for E, so we have to convert it to the required SI unit, which is meters, and that should come out as 0.1 meters. So putting that in the equation, K equals to F over E, we will have 0.5 divided by 0.1, and that comes out as 5 Newton per meters. Another example here, this time around, we have a spring has a weight of 750 grams hanging on it, and it is stretched from a length of 2.5 centimeters to a length of 10 centimeters. What is the spring constant? Again, we have the F for the force to be 700 grams, which is equivalent to 0.5 kg, 0.75 kg, and the extension, which is 10 minus 2.5, because the length stretched from 2.5 to 10 centimeters. That should be the extension should be 7.5 centimeters, equivalent to 0.075 meters. And putting that in the equation, K equals to F over E, that should come out as 10 Newton per meter. Hope this helped.